Okay, hello people. So in this video I will show you how to implement a std vector, at least how I do it. If you're interested, please follow along with me. I will try to focus on iterators more and try to figure out how do we remove elements using iterators, how do we remove ranges inside a vector, and things like that, reallocations inside the vector, when do we need to reallocate, and how exactly does it happen. Let's just start programming. Probably create a separate file for that, and we'll see how it goes. I will call it like the dynamic array.h. So that should be great. Pragma once, as usual. That's going to be our array, right? Dynamic array. And if you remember, if you take a look closer at std vector, it can contain arbitrary types, right? So the first thing that we will have to use, for example, create vector like this, and we can initialize it right away, which is really cool. The first thing that comes to my mind is that we have to use templates. So let's do that. And I will be writing like the usage code on the left side because it's way more easier for me to keep track of what I'm doing, and so like I don't try to implement everything and end up doing nothing, like because that happens for me occasionally. So yeah, I think the first function that I will try to implement is pushback. I want to like be able to create an element, let's say 78 or something, and maybe I will move this and if, since this code is unrelated to what we are doing in this episode. And I want to push an element into the vector. So how do we do that? Well, first of all, we have to include the header file. Include dynamic array. That's all great. So we have an array, and we have to implement this function. And usually what I do is, I don't know how to write vectors, how to write it in a good way. So what I would do is create a type alias for the t, so it's more explicit, more obvious, like a data type or maybe an object or whatever. But I will stick with data type. And we have to pass like data type, and that's gonna be our value. Yes, again, if you saw the previous episode, I started from scratch. I was writing everything in struct, but then at the end of the stream, I just organized everything nicely in a class. So that's the way I do things. I just start with a bare struct and put there everything which comes into my mind, and then when I have like decent functionality, I try to organize it better. So I will follow the same approach. The vector actually contains, what do we need? So we need a pointer to the data, which will be kind of a placeholder for all the elements that we push into the vector. We need the size element, which so we can query at any time and retrieve information, how many elements do we have inside the vector, and we need capacity. And the capacity and the size are two different things, because the capacity is an actual memory that was allocated for the vector, and the size is how much memory is occupied currently by the data that already have been pushed to the vector. So yeah, I will create like a data size t size and size t capacity. That's going to be our capacity. And so what do I have to do? Let me compile to make sure that everything works correctly. I just do it by habit sometimes. We need to check whether size plus 1 less greater than capacity. Oops. And if it is, we will need to reallocate or allocate memory. Don't have enough space. And otherwise we assume that here we reallocated all the memory, and then we say, okay, data size equals value, and then we increment the size, right? So that's what we do. How do we allocate memory? So let's say okay. Let me introduce like a default constructor. Size So yeah, actually you can do it in multiple ways, and usually like the C++ core guidelines don't recommend to do it that way, because there is no point to creating a default constructor if you want to initialize the values to defaults, right? We can do it always here, and that way we can eliminate completely the default constructor. Right. Here what we have to do is, and yeah, actually the important thing about vector is actually, if you understand how do we grow it, you can write like this kind of data structures on your own. So there is no point in, for example, when we don't have enough space inside the vector, there is no point to allocating a memory all the time for a single element. What I would rather do is if we run out of a space, I would multiply the size by 2 and allocate that much. So the next allocation will happen when we exceed, or when we exceed all the elements. Like, yeah, I can show you basically. It will be easier for me to show in the code. But what I was trying to say is that we will be implementing vector that way, so we don't allocate memory for a single object at a time. Rather, we would allocate exponentially. So yeah, we'll be multiplying basically by 2 if you don't have enough space, and that allows us to reduce the amount of allocations and the allocations we have when pushing elements into the vector. It will be more efficient. So we have to figure out how much bytes do we need to allocate, right? And that would come from, as I said you before, we have to multiply by 2 plus 1. Why plus 1 is because, for example, let's consider that the size equals 0, then we multiply by 2, it's going to be 0, right? And in that case, we'll have to add plus 1. Yes, so that's going to be our allocation size, and probably I would rather say it's like a new capacity, because we enter this if statement if size plus 1 greater than capacity, so we will have to change the capacity. And the capacity would be plus 1 multiplied by... no, that's correct. So that's gonna be our new capacity, and what we do is saying, okay, malloc. Yes, I will be using malloc. You can use new or delete or whatever you want, but just for me it's way more simpler. But probably for large objects we want to allocate memory and call the constructor for them as well. I'm not really sure, but I will go this way and see if I bump into the wall. Then I will try to rewrite. Then I will rewrite everything. Have to figure out how much bytes do we need to allocate. So the allocation size would be new capacity multiplied by data type, the size of the data type, right? And then it will be allocation size, data type, oops. New data. And we will have to cast. Okay, so let's use like a static cast. Let's go completely C++. We can check whether new data is valid, so whether the pointer is valid. So what we probably have to do is include assertion.h. And what happens next is that we have to zero the memory that we allocated, right? I can use calloc, calloc, but I want to do everything explicitly. So I just memset and new data allocation size. So I will clear the memory that I have allocated to 0. So everything is 0 initialized. I don't have any rubbish like values. Okay, and what we do next is let me double check whether I'm still recording. Yes, I do. And then what we do is we mem copy the data that was stored in the data pointer previously, right? So we have to copy to the new one because that's our reallocation. But we don't know really how much do we need to copy. So copy size, and that will be size multiplied by size of data type. The previous size multiplied by size of the data type. That's how much bytes we need to copy, and the new data will be the destination, then the data is going to be the source, and copy size. And what we would have to do is we would have to free the data, and we would have to update the capacity to a new capacity. So that's kind of the sequence that we'll have to follow. And then we write the value and then we increment the size. Okay, so it looks good to me. Let's just try and put some values into the vector and see whether we crash or not. So push back. We don't have enough elements because if you take a look at the watch window, capacity is 0 and the size is 0 as well. So the new capacity, yeah, okay, we don't have, is equal to 1 because 0 multiplied by 2 plus 1, 0 equals to 1. And then allocation size would be 4 because that's the size of 32-bit integer, 4 bytes, right? And then we receive the memory back. We make sure that it's valid. Then we clear the memory, because if I take a look at the pointer, not in the data, but in the new data, it has some invalid values. So we'll have to set that to 0, and then the copy size is going to be 4, exactly what we expected. And that is the problem. Oh, now it's actually multiplication, because not plus, obviously. Yeah, and then we free the data, but it was already 0. Probably we have to check. We have data capacity, which equals 0. Yeah, and one more important step that we would have to do is we would have to assign newly allocated memory to the data, right? And we actually can check if the data, then free, and then assign, and update the capacity. Okay, we updated the capacity and we put the element and we increased the size. Everything works fine. And right now what I want to do is to print the value and make sure that we pushed everything correctly. So element I'll just dereference it, but no, actually I cannot, because array data, and yeah, I will just dereference because we don't have any operators overloaded. We will do it in a second, so it's way more convenient for us to see what we are doing. But here is our element and everything works fine, and yeah, I would have to put a destructor here to make sure that we actually freeze the memory, because that's important. I will take that. Yeah. Okay, so here is our element, and let me actually implement the operator like access by index operator, so we can, instead of the referencing, we can just say okay, array, and provide an index, and that we get an element back. And I will implement two of them for const arrays and non-const arrays. So the difference would be that this is const and this is not. So I will return, oops, the reference, and then it takes an index, right? Probably it can be unsigned, but I don't know, I don't really care. And here we have to make sure that the index is within the valid range, right? which is less than the size, because otherwise we'll get an overflow. And then we get the index, and we do the same. And we have an assertion here as well to make sure. Yeah, probably should have copied. Let's do it so we don't lose time. Index. Okay, so that's correct. We have some error that, okay, we don't have index. That's my bad. Yeah. And right now, instead of doing this, we can just do this. Return cannot convert from int pointer to int reference. Yeah, I know where the issue comes from, but I'm thinking maybe it's better to return the pointer. No, we have to return the reference, because otherwise we won't be able to write to that memory. And we can return the pointer as well, but... And here is our value. So that's correct. Okay. Now what I want to do is I want to introduce I think, let me think for a second, because we have the pushback, right? And yeah, let's just go for like small functions, whether the vector is empty, the size and the capacity, like all of those things. So later we can focus on reallocation and like pushing ranges into this vector, or erasing rather vectors, etc. But I will just implement pop back for now. Pop back. And what that would do is we'll just decrement the size. We'll decrement the size and back. Okay, so we can get the elements enter to the t, back, item, and pop. Okay, so let's see. Let's just yeah, I think like when we're requesting for the back element, we just want to take a look at the last element. Let me take a look at the vector implementation, what they do, because I'm not sure. So I can bring it here so you can see. Okay, so we have pop back, removes the last element, and insert, clear, and some other functions, but I think the back is pretty important. I don't know, but it would be nice to have, so we can get like the last element in the vector size -1. Oops, size -1, and obviously we cannot modify it. But we would have to check whether the vector is not empty. So we would have to do this. Okay, so it's getting more complex actually, because we would have to return then std optional in this case. Optional. I would do that. And okay, we return this, but otherwise std. I never used std optional. I only heard about it, but let me just compile to make sure that everything works as expected. Okay, so we complained about optional. Let's see. So it returns an optional reference to an optional. That would be a const, but I'm not sure. Maybe I should put inside like this, or Okay, so basically what I'm trying to prevent is the situation when we don't have any elements in the vector, and we just don't want to subtract 1 from 0, right? So because we'll get a negative value, and we will try to access the data by the negative index, which is undefined behavior, I assume. And I want to, but I still need to return something, right? From the, I cannot return like multiple types, right? Either like true or false or 0, or for example, an actual value, right? So that's where std optional may come into place. And what we have to do is we can check whether the size doesn't equal 0. If size equals to 0, then we return an instance of std optional. Otherwise, we return no idea how to use optional, but let's try. And let me read about it. So I don't shoot myself into the foot. Okay, so we can read together, I assume. The class template is the optional message manages an optional contained value that may or may not be present. Okay, so it's actually a pair which signifies whether the value is present or not. Is the return value of a function that may fail, as opposite to the other approaches such as the pair handles expensive to construct objects well and is more readable, as the intent is expressed explicitly. Point in time either contains a value or does not contain a value. Contains a value as a value is guaranteed to be allocated as part of the optional object footprint. No dynamic memory allocation ever takes place. That's great. Thus, an optional object models an object, not a pointer, even though operator undefined. Contextually converted to bool, the conversion turns true if the object contains a value and false if it doesn't contain the value. Okay, so we can use it even in this if statement. So that's great. So we will be able to do this. Auto array auto item array back. No suitable conversion function from auto, and if we got an element back, last element item, not swap obviously. Oh, we can, I think we can dereference even. Yeah. So what are you complaining about? Okay, so that's an actual error. Illegal union member is a reference type. So I guess that's exactly what I wasn't sure about. The optional. Let's take a look. So we're getting the element back, but I'm worried about those warnings that I have. Does it have like a usage example? Yeah, okay, so here I've returned a string and so we don't even need to use braces, right? And we still have a warning. But okay, let's I will put it to do. And so we can focus later on it. But optional, like, seems reasonable for me, at least for now. So we return the back element and we won't be able to modify it, right? Item value. Just want to check whether we can do it or not. Yeah, we can overwrite. We can overwrite the value. But we need to prevent that. Illegal union member is a reference type. I cannot return the reference type. Okay, I assume what I would do is I will try to do this because I have to read more about std optional and how it works. I have never used it like in real life. What I will do instead is I'll have to make sure that size is valid, and then I will return an element. That would be a better approach. Yeah, and that's illegal right now, which is correct, and we get the element back. And we can okay, we can print that out. So here is our element. Yeah, and that's better approach. So we don't get a negative index. But let's continue. We would have to implement like a declare function. Yeah, and let's test the pop back array pop back, and that actually removes an element. And I will introduce one more function which does size t length, which returns the length of the vector, which basically the size member, right? And length okay. Zero, and that's correct since we pop back the last element, which is fine. We just reduce the size. We can get a capacity back. I don't know why would we even need that, but just in case. Maybe we just want to know some information about how much element can actually fit into the vector until we get to the relocation. So here is a capacity. Yes, okay, and I can implement like the clear function. What it does is after calling the clear function, the size of the length should return 0. So what we have to do here is just set to 0, right? We don't have to do anything with the memory itself, we just set the size to 0. We can push multiple elements. Let's create like a for loop. Oops. 0 and plus plus I. I will make it a little bit like this because I know that there is my picture somewhere here. Let's push 3 elements into the vector and plus index. Doesn't really matter, but I prefer indices to name it like this, and increment, and then array push back index, and that's going to be our element. And then what we do is let's make a function which will print the array itself. somewhere here, template, type name t, or I would rather say, okay, class has to be static, and I will have like an out, I will call it out, and that would take our array with an arbitrary type, and that would take a reference, obviously, array. And what we will do for now, we will not use any iterators. We just create like a regular for loop. So we increment like the index and v++. Okay, and that's what we do. And here we have to get by the index our array, and that's actually, in this situation, we will call this function since it is a constant array, right? So we will get this operator, so we won't be able to modify it since we're receiving a reference back. But in this situation, we could have write something to it, right? Like 12, but we cannot do it right now. Okay. And that's why I marked it const, because we only need this function. We only like want to print and not to modify the vector itself. So I will print the vector an element, and what I will do next is I will check whether this doesn't equal length -1. Oops. I would do this. I would put a comma. So that's correct. Let's just compile to make sure that we don't have any errors. And that works fine. Let's print our array. See what elements do we have here. Okay, and we have 0, 1, and 2 since we decided to put 3 elements into an array. And let me just an array clear, and after clearing, after array clear, and I can actually put a breakpoint to make to show you that we call that function inside this procedure, the version that is constant. So after clearing, we have like the size, the length will return 0, and since we're iterating in the for loop over all the elements, and the length will return 0, right? So we don't have anything to iterate over. And I will put one more thing here, a semicolon. Okay, so we have clear, and we have the capacity, length, back, pop back. That's correct. Is empty. Maybe I will just stick with empty. I will create a type alias. because I'm saying it all the time, it's better for the CPU if the variable is aligned by 4 bytes boundary or 8 bytes boundary. Size equals 0, and use an assertion empty, or we can actually use the length here, right? Since the length returns size, so we can use length equals 0, or we can even use this. Yep, we succeeded. Okay, so that is done. I just want to implement all the simple functions, so I have time to implement like the reallocations and iterators and things like that. But we are going well here. So the back element, the pop back, and clear, empty, the capacity, the length. Okay, I think the next thing that I will implement is pushback, but this time I will use data type R reference, basically, so I can because if you notice, probably you didn't, I should show you. If you, for example, decide to do this, push back, and I put 1 here, it won't work because, let me run the program or compile the program. No, it does actually. What if I remove const? Yeah, okay, now it's complaining that initial value of reference to non-const must be an L value. Yes, okay. So I'm confused right now. What if I do this? Do we call this function or this function? Yeah, okay. They are calling the right one. And if I make, yeah, because it's not const. Let's do this. Yeah, okay, and that's correct. I think we can even remove const here because it's not really necessary. We can take a look at the vector implementation. Std vector int to the t v and v push back 1. So let's take a look. And we push in by a value, and we have the const reference. That's correct. So now we have to implement this part, and this would be identical to this, right? But I want to avoid the duplications as much as possible, so probably have to play around with it and create like a separate function which does the reallocation. The only difference would be that would have to move the value instead, right? and this part would be the same. This. Yeah, I will create a function void row. And I will put everything inside of it. And then grow. Because here we only we only change the capacity, right? And yeah, nothing else. So we would have to do the same kind of an if statement. And we can even create like a helper function should grow. And what that would do, I think what I would do instead of instead of checking should grow, I will just click size t count, and I will specify if the count is greater than the capacity, then we have to grow. And here I'll just call fit and size +1. Okay, and that should obviously be a private function, and that should be a private as well, but we will deal with that later. And let me just make sure that we compile, and we don't. So we have like a syntax error somewhere. Yeah, I forgot a semicolon. Yeah, but it works correctly. And let's add like a couple more elements. Pushback 24, array pushback 56, whatever. Pushback 78, for example, and then the out and array. And we'll take a look what it contains. So it contains all the elements that we pushed, 1, 24, 56, and 78, which is correct. Okay, let me take a look. How do we copy? How do we copy vectors? I don't know whether that's a good idea to implement a copy right now, but maybe let's play around with iterators a bit. So iterator is just a pointer, right? So it would be data type iterator, and it's just a pointer. So nothing special here. And I want to have a regular iterator and the const iterator. So those things, and I would love to have like a iterator begin and return data 0, and that would be an address of an element, right? And we can implement iterator and as well. So that would be an address of size. An address of size. And usually you might think that we have to subtract 1, but an AND iterator is one element after the last element, right? If we, unfortunately, I don't have like a tablet and I cannot draw it for you, and that would make more sense in terms of understandability. But we have to make sure that we iterate over all the elements except like the one which is after the last. Yeah, if we, because we will be using it in a for loop. 1 past last element. Points plus 1 past last element. And I will do the same, but for the const iterators. That has to be const, obviously. So we cannot modify the data accessing using the iterator. And that would be and. And that would be size as well. Yeah, and okay, so that should be correct. Okay, everything works fine, and I would have to, let's make another function, analogy to out, but this time I will use the iterators, so I will just copy that function and name it something like, I don't know, iterator, and instead of just using an index, what we would do, okay, so what we would do is grab that const iterator begin equals array begin, and we can do it in a for loop. Begin. Okay, maybe we can't really. And then I can do the same for the AND iterator. AND equals array AND, and then we have a for loop. And obviously I could have simplified that by just doing auto value. It's not really a value, but const auto entry and array. That will work exactly the same way, but I just want to be as explicit as I can. So begin doesn't equal to AND plus plus begin. So that's correct, and we do this here. And right now we don't need to rely on the index. We can just dereference the iterator and get the value back. And here what we can do is we can check whether the begin iterator doesn't equal array, and we shouldn't even use that. We can check and -1 -1 or -2. Yeah, -1. so we don't print the comma for the last element. And let's compile, and we have a lot of errors, obviously. So the begin and what are you complaining about? I expected a token identifier following expression. Huh. Okay, so that is strange. They have to put const? I don't think so. Okay, yeah, I do. And so we push in the elements, and let's do the same but with iterator, and let's put the array. And so I can show you. I'll put the breakpoint here and here. You cannot assign to a variable, but I'm not trying to assign. That is const. But am I really trying to assign? I don't think so. Well, we could do that. Auto. Okay, and they have the same type. So what I can do is begin equals this, and equals this, and so I can remove those two lines, and let's see what happens. And okay, we hit in the breakpoints here, which is correct. When we try and iterate over the data inside the for loop, inside of when we're trying to iterate over a vector, and here we print in the vector, but using the iteration loop. Okay, and we could have obviously replace it with auto item and array, iterate over array, and that has to be const, I assume, and then we could print everything as well. Print here. But it doesn't really matter, both cases are good. Oh, how much time do I have left? 2 hours, okay, yeah, that's fine. So let's continue. Let's continue. So we have the iterators. Let's try implement the copy. So after many hours of programming, your typing skills get only worse. it was proven. So we have a reference, and that would be the source. And what we do is we initialize the size to source and the capacity to source capacity, and yeah, I think that's it, because for the data we would have to allocate our own memory. So what we would have to do is we have to grab the allocation size allocation size, we take the capacity, we multiply it by the size of the data type, and we malloc the allocation size, and then we static cast. Pretty much the same thing that we were doing previously. I should have copied that to save a bit of a time, but yeah. And that would be the data, and we have to assert that the data is valid. Data, okay. And we just have to mem set data 0 and the allocation size, I assume. So we have to 0 all the memory that we have allocated, and then we have to copy size t, copy size would be size multiplied by size multiplied by size of the data type, right? Because what we are trying to do is we are trying to copy all the elements that were in the source to the destination, and not the capacity, only the elements that were actually there, right? Let me have a bit of a water. And yeah, and we have to memcopy the data and the source data as a destination and copy size, right? That is correct. That is correct. And let me just test this function quickly. So, okay. Array int 32.t, array 1 equals array. And out iterator array 1. So I will put a breakpoint and cannot convert from const array to size t. Oh, right, because that's going to be the size. Okay, and we have to step inside this function. So I have to make sure that we do reallocate the memory correctly. So we have a capacity and the size 7 and 4, and then we compute the allocation size. Then we allocate the memory, which is like 7 by 4, 28 bytes, which is correct. Probably we can make it even aligned, but that's for the separate video. So we always align by 4 or 8 byte boundaries. So whatever. So let's assume like we want to allocate a memory for a single byte. But in that case, if we are on x64, we will allocate memory for 8 bytes, and if we are on x86-64, we allocate 4 bytes. So we always have this follow this alignment, right? and that will be easier to have the data to hit like the cache line. And that's our array. Yeah, so we have copied correctly. Yeah, and that's the copy constructor. And copy assignment operator has exactly the same signature, but we'll make it a little bit different because we have to. Okay. Well, first of all, it has to return this pointer, the reference to this object, and so what we would have to do, we have to check whether the data, and then we free the data, right? Because it may contain some elements already. So we'll have to freeze the memory and then kind of do exactly the same that we were doing. And I can put it into the function as well. So, and we set the size equals the source size and capacity equals source capacity. And then the capacity multiplied by size of the data. Then we malloc. Then we assert again. Then we memset the data by the allocation size. Then we copy the data. And that should be fine. That should be fine. I'm thinking maybe I should call that function something like a realloc or... Yeah, but we already have grow. We already have grow, which does pretty much the same. Yeah, but this line is different. This line is different. Okay, we have like a little bit of a duplication here, but alloc and copy. But then we would have to pass a source, and yeah, it makes things even more complex. So yeah, I would try to deal with that in the future with this duplication because that's not great. That's not great at all. At least what we can do, we can create like an allocation function and alloc size, and we can put we can make it like this, and it returns a void pointer. Result equals, and we don't need to cast, or we can actually, yeah, let's so we allocate the memory. That's actually the problem when your vector has to do the allocation as well, not only just inserting the elements, but allocating and managing the memory. And usually, if you're familiar with the implementation of STD vector, we use STD allocator, which does everything for us, and we only have to push elements and things like that. But yeah. And I assume I have to like memset. Okay. Alloc and 0. Allocation size, and then the result. So just to simplify things, what we could do instead, we can say, okay, data equals alloc and 0, and we provide the allocation size only. So we don't need that. It's a little bit cleaner. And then we copy the memory. Okay, so that looks better to me. Why it always removes the last word? I don't understand. Okay, so we don't need this, we don't need this, we don't need this. Yes, that's better. That's better. Because we know that we already check whether the pointer is valid, and we set it to 0, so that's correct. We can even use an iterator because that's technically the same, but I will rather stick with a type because not to confuse. And here we compute the allocation size. Okay, and what we have to do is alloc and 0, alloc and 0. New capacity. Okay. So that is better. Then we have the copy size. We copy the elements, and then we have to make sure. Yeah, that looks better to me. At least a little bit cleaner. We avoid some code duplications, things like that. Let's just run the program and make sure that everything works correctly. We don't have any memory leaks, and I hope we don't. But I probably have to step through it in order to verify, in order to be sure. Let's continue. I wanted to test the copy assignment. Array1 equals, let's create like a array2. I would love to have an ability like to specify this, but unfortunately I can't because we didn't implement yet the constructor with initializer list. So I cannot do that. I would have to create a function and additional functions which simplify our lives for now. So we can field the vector by calling just a function. Populate or something, I don't know. and it should come by reference out array, and we have to specify how many elements we want to fill, and yeah, just boom, boom, boom. Sorry, array out array, and that would be index, and that would be index as well, right? Yeah, okay. And then we can call populate and the array itself, which will be passed by a reference. Let me press 2, and how many elements do we want? Let's just specify 6 elements. And then I will invoke the copy constructor, copy assignment operator, and then use our iterator in order to print the array. Okay, and I will put a breakpoint somewhere here so I can step inside. That's bad. Okay, so we have an assertion that index is greater than the size. Can I take a look at the index? Oh, actually less, or no, it should be less than the size, but when the index is 0, so let me think about how to handle the situation, because the vector is empty and we are trying to index and we're trying to use this operator and we fail, but technically we shouldn't. Since we want to put an element by an index, right? Oh, that's actually the problem. We cannot really do that. Because we will have to push back, right? Yeah, okay. Yeah, right, we'd have... That's correct, we'll have to push back. We'll get the same behavior with the vector because we don't have any elements in the vector and you're trying to assign to a particular index, but the vector itself is empty, right? And it's nice that the assertion helps us to catch that bug, and it's not a bug actually, that's the desired behavior. But yeah, what we have to do instead, I was confused a little bit. We have to use a pushback and push an index. And that's how we populate the array, and then we can iterate over. So yeah, great assertion, saved many hours of debugging. And we copy in, and here is our array, which is great, always. Okay, so let's continue. Let's implement like the move semantic, and I will move the destructor close to the constructor, so everything is aligned properly. Not a perfectionist, but yeah. And that should return the data type. Data type. And here would be the move constructor. Okay, data type, source. Let me compile to make sure that everything works fine. Yeah, it is. And what we are doing, we're saying, okay, so this, yeah, we can even do this, like size equals source size, and the capacity equals source capacity. The good thing about moving is that we avoid copying the elements, and we avoid memory allocation. Because if you are using the vector as a D vector and you have never implemented it on your own, you don't know that, for example, copying elements, copying vectors is more expensive than moving. But now we know that in order to copy the vector, we have to do the memory allocation first, and then copy the elements here. But with moving, we avoid doing that. So we're just saying, okay, data is a source data, and then we have to clear the source. Source size equals 0, source capacity equals 0, and source data equals now pointer. So that's correct, and I will test that in a second. Don't take a look at that. It's my like direct text code. It's unrelated to the topic that we are working on currently. Operator equals, and what we have to put here is exactly the same signature, but in the move assignment operator we cannot use initialization list, so we would have to do everything manually assign the function body. But the idea is pretty much the same, except that we have to return a reference to this object, and I will copy this as well. So size equals size equals source size, capacity equals source capacity, and we have to check whether the data is valid, whether it contains something. We just free. No, do we need? No, we don't. We don't need to free anything. What we actually do. I think we might need to free the data that was there previously, if it was, obviously. And then we set, okay, so here is the data, and set it to the source data. And then we null everything for the source, clear the source. Clear the source. So that is correct. I'll put a breakpoint here and here as well. Let's just compile. Okay. Great. So let's move an object. Array, let's create a different array, array3 for example, and array3, populate. No, let's just move it back. Array1 equals std move array, just array, and out array1 and out iterator array. Yes, we call in the move. Why do we have? Okay, so we are not hitting. Yeah, because yeah, that's correct. We hitting only move assignment operator, and so we have a new size. We update the size, and now let me just go through it because I didn't notice. Okay. So the current capacity is 7 and the current size is 6. So the size becomes 4, the capacity becomes unchanged. And then if the data, we freeze the data, and then we point to the data that was inside the source, and 0 capacity data null pointer, and return this, and we print both of them. So the last element that we print has nothing in it, and the previous element has the contents of the vector array of this one that we created like in the beginning. And that is always great, but let me test another thing. The creation. Array3 std move array array2. Okay, and out iterator array3 and out iterator array2. That is correct. And let me put a breakpoint here as well, and put a breakpoint here. Okay, so we hit in the right breakpoint. I'm happy. We change the okay, we set it already here, so that's correct. We just have to zero the source. And here is the source, and here is array3 currently. That's correct. And you know what? We can even make a macro. Define out array. No, we can't. I was thinking about maybe we will be able to print the name, but well, I think we can. So what we would have to do is okay, let's see. Array so we'll do it like this, and then we call this function like array out out, and then we pass an array. Should work. And I think I would do the same for out iterator array. Okay. What are you complaining about? Okay, we don't have that thing. And now what we can do instead is out iterator and use a3, and out iterator we can use 2, and we can remove this, and we can remove this as well. And let's see how it behaves. No, that's not what I wanted. Yeah, so those two we print correctly, but the other ones we don't. So we would have to go through them and replace out with out. It's not that much. Yeah, that's way more better, actually. That's way more better. Okay, so we have like moving, copying, and we can grow the vector, that is correct. And what else do we need here? We'll probably need like yeah, let's just try to implement an initialization list. So std initialization list. Okay, initialize a list, right? Data type, and then you have to specify it as a list. And if you see, we have only like begin and end and size. We don't have anything else. So we need to create a function which would insert all the elements based on iterators. So we provide begin, we provide an end, and it will basically insert all the elements. So what I would do is maybe I can write push back, can write something like push range. And here what we can do is we can call push range list begin list end. That should be fine. And it should accept begin, and it should accept end. And how do we handle that? Let's see. Can we reuse the functionalities that we already have? simple. We can use actually at begin at doesn't equal and plus plus at. Can we do that? Yes, we can, and then push back at yeah, that would work, but probably we can even do this. Push back const iterator, and we have to make sure that iterator is within the valid iterator is greater than. No, I don't really like it, this approach. It's better to the reference. And let's experiment a bit with initializer list and array introduced to the t. Array 4 would be equal to 10 or whatever, some other numbers, 7, then 99, then 100, 4, and that would work. And then we use the iterator, so we can print an array, and that would work as well. Let me put a breakpoint inside this function. Let's go through it. Okay, so we push range, we iterate over, and we push all the elements that we have. Yeah, we fit. We have to make sure that we fit. Okay, we do. And here are all the elements that we have, which is great always. So that's how we push the range. What else do we need? Probably it would be nice if we could somehow figure out a way how to erase a particular element by the iterator, right? So for example, array 4, like erase array 4 begin plus 2. So that's the function that we'll need. And where do I need to put it? Probably let's do it here. Erase. And do I need to use the const iterator? Probably. So what we would have to do here, since this erasing is a little bit complex, because if you erase an element in the middle, then you have to basically move all the elements that were after and decrease the size. So we have to iterate over the like, yeah, you basically have to move all the elements one element left in order to have the correct structure. So let me think, how do we do that? Well, let's first of all probably assert that greater or equal than begin and iterator less than end, right? To make sure that we are at least in the valid range. And then what we do is we can, let's see. Okay. We have to. No, it's not actually a const iterator. It should be it should be just a regular iterator, no? Iterator, no, okay. Let's just use a regular iterator for now, because I don't know how to handle that with const. So we set it to the iterator, then doesn't equal and plus plus at. And what we do is at equals iterator plus 1. Right? Because since we removed like an element in the middle, for example, the next element that will occupy his place will be the one, the element which is right after that. So that's why we have to add 1. But we have to check. We have to introduce a check for the last one. So it's basically we have to do that operation until like at let me think for a second. Doesn't equal and -2. And the reason why it has to be -2 is because and not just -1, is because when we get to -1, it's going to be the last element, right? And the iterator, since we and we have to increment it as well. And the iterator will point and to the last element, and if we add 1, it will point to one element after the last, right? So that's why we have to subtract 2, I assume. That would be correct, and we have to decrement the size. Yes. So, I mean, if you are comfortable with pointers, iterators will be like this for you. It's nothing. But only if you are comfortable with pointers. So, before erasing, and that's like this, and let me put a breakpoint here. Yeah, okay, so we're trying to erase the last element. I'm not sure whether that was correct. So which element we tried to erase? +2, so 1 to 78, I assume. That was the element, and we successfully erased it, right? And we moved all the elements back. So, but we have 99 in 2 places, which is not correct. Why it's like this? Let me see. Why do we have 99 into places? So doesn't equal to and minus 2 plus 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 1 and set at. Well, I don't know. I don't know. I have to debug. So let me take a look closer. Greater equal than begin. In what we do. We increment the iterator, which is correct. Doesn't equal and. Well, first of all, we can do this plus plus iterator. So it's more obvious what's happening. Let's see. At iterator. So that's the element 78. And we write in 99. So we override that element. Okay, why do we do that? Why do we skip? No, maybe it's actually -1. Right, okay, so -2, it was too much. I thought like yeah, okay, because it's a pointer. With indices it would be different because it's a pointer. Right. So yeah, if you saw, we just skipped an if statement because we already reached the point when at iterator was equal to and -2, which is incorrect. We have to check whether it doesn't equal to the last element, not the one before the last. Yeah, because for the last element we don't need to set this at all. Like we don't care. We just don't care about the last element because we'll never use it. We decrement the size. Yeah, and the size will be less than it was before. So we just don't care about the last element. And based on that, I can now implement something like arrays range. Iterator start. Okay, range start. Iterator range and. So I can do this, for example, arrays range and array for begin. Oh, let's actually try to erase let's try to test some edge cases. What if we erase the first element, begin? Erasing the first element. Let's take a look. And yes, we did it successfully. We removed the first element and the size was 3. And let me check like for the what happens if we remove the last element. Removing the last element, undo, out iterator, and 4, but we have to actually erase the element and. No, but it's not and. Okay, so we have to hit an assertion. Yes, okay, exactly, because and iterator is out of the range. But if you want to remove the last element, we have to subtract 1. That is weird. -1. Yeah, that is weird. Let's try and see what happens. Okay. Less than and. Oh, because I was using different array, obviously. And that's why I have a check that the iterator is within the valid range. It's super important when you're dealing with pointers. And yeah, we removed the last element as well, which was 104, which is correct. And let me put a couple of elements, populate array 4, like 5 elements, and let me print it out. So that's the vectors that we have currently, and let me array 4 erase range. Erase range, array 4 begin. Let's erase out erasing a range. Erasing a range. So let's remove like beginning +2 and array 4 begin +7. No, that would be too much. +3. No. Okay, so let's do this 1 and 5. And we'll print it out and see what happens. Oh, okay, we didn't implement the erase function. I would have to do that. So I would have to check whether the range start is then begin and range range and range start less than and we do the same for the range end. Right, so that's what we do, and we actually have to make sure that range start less than range end. And we have to compute the elements arrays count. Arrays count is going to be range and minus range start. So we compute that. Since right now it's valid operation, since we verified that they're in valid ranges and start is less than the range and. And what we have to do is okay, so we're removing range, for example, in the middle, and what we have to do is we have to move all the elements back. So that should be straightforward. Again, we have to use a for loop and size minus equal to arrays count. Size minus equal to arrays count, and basically I'm saying that iterator at equals range start, range start at doesn't equal range. Okay, now wait a second. Yeah, okay, I can do at equals range and doesn't equal and actual and then plus plus at, and then v range start plus plus equals at. So that's what we do, I assume. Let me put a breakpoint to make sure that everything is correct. Okay. Yeah, okay, so we removed the range correctly, and we removed from 99 to 1, and from 99 5 elements. 1, 2, 3, 4, 5. Is it 5? Okay, from the beginning 5 elements. So which means like 1, 2, 3, 4. 1, 2, 3, 4, and 5. And this should left, and this element should left as well. Should be left. So that looks good to me. Yeah, I just have to last bit size array for lengths, and you saw that the capacity was how much time do I have left? Okay, 2 hours. That's great. Std and all, and then I will put one more element, push back this element, and then I will do the same but for the capacity and I will at the end I will clear the vector, and then I will get the length or the size or whatever, doesn't really matter, and that's would be it. Okay, so let's see. So we have 3 elements, the capacity is 7, but then we push one element Yes, and the capacity increases to 7. So we push an element before we display the capacity, and then we clear out the vector and it equals to 0. So yeah, I think I will be finishing for today because I'm super tired. And I hope it was helpful. At least you could have learned something. You could learn something, and yeah, like if you want, you can make a class out of it. But I don't know. Actually, we'll keep it as a struct. There are things, some minor things that we will have to handle, but all in all, it looks good to me. I will put a code in the description so you can play around with it on your own. Yeah, see you in the next video. Take care.